conference. It's my pleasure to invite for presentation Professor Gia Sirbiladze. Short introduction. Professor Gia Sirbiladze is a leading expert in the field of intelligence simulation modeling, fuzzy decision-making problems in uncertain environments, system research and engineering, and others. His research interest is in computer science and includes systems science in engineering, fuzzy technology in decision-making support system, extreme management. He has more than 40 years of experience in teaching and research at the Javahishvili Tbilisi State University, Georgia. He is a professor of applied informatics at departments of computer science. This university, he is member of several international society of computer science and engineering, such as IEEE, MICOM, and so on. He also member of editorial board of various international journals in computer science. Thank you very much, Professor Sirbiladze, for your contribution with our conference. We have time for your keynote lecture. Welcome.
Okay, thank you very much for your introduction. And do you see and listen me?
Yes, we see you.
Okay, I'm starting now. I start.
Yes.
Hello.
Please share your screen.
It's my pleasure to be invited in a very good conference. Thanks, conference organizers, for my plenary speech. And today I present you new directions on the so-called expert knowledge streams analysis for the analysis of complex processes and events based on the well-known Azades logics environment by our creating methodologies. More concretely, I present temporalized technique for the construction or more precise decision making. And as an example, we'll consider at the ending of my presentation problem of information security risk assessment. So you know that when we're working, we are working.
Excuse me. We don't see your presentation. Please share your screen.
Oi.
What's it? Present now. How do we do the window? Hello, really at Plenary. I hope we have to share. Do you see it? Do you see now?
Do you see now?
Yes, please full
screen.
Now? Yes?
Yes.
Okay. So we are from Tbilisi State University. I work at the Basic University of Georgia, and we have some group of researchers and professors which works on the intelligent systems and artificial intelligence methodology for the investigation of complex process analysis, such as information security management problems in some directions. So when we're working on the complex process analyzing, usually we use time series analysis methods, but sometimes when some critical parameters will be evaluated, it is not sufficient to use such as objective time series analysis methods. And in such as cases, we usually use experts' reflections or experts' evaluations on the processes. by some evaluation of risks and some extreme parameters subject by the subjective evaluation. So we create so-called expert knowledge streams. For this is time series, but practically the source of these time series is not object, as in these usually stochastic cases. In this case we have expert is only one source of such as information. So we have some different aggregation instruments for the making good and believe understandable analysis with respect to so-called prediction, identification, classification, and other synthesis methods. So today we'll consider one new our approach dealing of the analysis of expert knowledge streams. So at first we consider so-called delta shape belief structure.
Excuse me, Professor Sirbiladze.
Yes.
Maybe two problems we have. Please full screen of your presentation if it's possible, and changing of a slide we need check, because maybe you
Changing. Stop sharing.
Please repeat, please.
What? Repeat, please. What is the problem?
Problem is, please, if it's possible, to share your presentation on full screen. Now we have left side with.
You can continue clicking at the left panel to allow us see the content of your presentation, or you can share not the window but the entire screen, and in this case we will be able to see the full screen mode. Or it's enough to click at the left panel the exact slide that you want to show.
This is the maximum, I think. This is the maximum.
It's okay.
Window.
Please continue.
Okay.
May I continue my presentation?
Please.
Okay.
Please continue. Okay. Please continue.
Hey, may I continue?
Yes.
Okay. Well, thank you. So it's very known Debster-Schaeffer structure, belief structure as a body. So this is some extension of two different theories of probability statistics and so-called possibility theories by Dubois-Pradet, developed by Dubois-Pradet, but this theory was started by Zadeh in the in the previous century. So what is this? About this structure I present on my following presentation, but for the starting I tell you that we created temporal environment of the structure, which will be used for every decision-making heuristic environment for the temporalization of these methods. And this temporalization scheme may be used for the creation more precise decisions in this environment for the different very difficult problems, for such as information security risk assessment and so on. So our research is concerned with modern information theory and analysis of the complex uncertainty and its use for precision of information processes and decision modeling. The most important of such as analysis methods are the theory of body of evidence, or Debster-Schaeffer belief structure, and parallelly so-called well-known Kaufman's theory of expertons as some credible and believe methods for the decision-making problems. Temporalization theory of body of evidence in the environment of theory of expert tones means the construction of information precision, relation on the bodies of evidence using theory of expert tones. So, by some words on the Defter-Schaeffer belief structure. In probability and statistics, the basic initial information as a mass or initial probabilities always is given for the singletons or the elementary events. After this, for example, for the finite case, as a sum of supporting probabilities of supporting elements for some events, okay? But sometimes in complex problems, we have no any information on the singletons. But it's the mass or frequencies or maybe so-called focal probabilities, so the subjective probabilities may be given for some concrete events or subsets of the universe. Maybe these sets may be joined. So this is some generalization of probability theory, and probability theory is one variant of this structure, because if in the role of so-called focal elements, for this probability is strongly greater than 0, which has some information or mass about this process. So in this case, we have so-called dissonance body as a probability environment. And in general, these two elements, focal elements, which has a positive mass as a positive information about some events, about some process or experiment. And the second parameter is a focal probability. As a pair is called body of evidence. In this theory, the main are two information measures: plausibility information measure and belief. By these measures, we create analysis for the processes, maybe more complex events and some more complex problems dealing in the level of Defter-Schaeffer belief structure. So, for example, what is the belief of some events? You see by this formula, belief is presents the total evidence or total information on belief that the element belongs to this event, as well as to the various special subsets of A. What is a plausibility? Plausibility is a more freedom, maybe freedom of as a total evidence of plausibility that the element belongs to this element. But in this case, the mass or probabilities of some focal elements will be summed for all such as focal elements which has some joint environment for this given event. So in some cases where this structure of focal elements are nested sequence of focal elements, we say that we are in the possibility environment. Now I don't present the possibility for this element because it takes many times. So I go to on the concretization, how we create temporal environment for the Defter-Schaeffer structure. Concretely, we consider finite and simple case. This systematic presentation of temporalized state case of Defter-Schaeffer structure, where we have some states or systems, or maybe this will be acts or symptoms or factors, or maybe attributes and so on. Also, we have some sets and maybe given some sets of decisions or alternatives or symptoms and so on. temporal environment will be present type algebraic structure T. The primitive, in our case, it may be integers numbers set from 0 to some n, and will be the ending time of our temporalization procedure. I is the information about the system. Usually I presents Defter-Schaeffer structure. It may be dissonant case, consonant. For the probabilistic, it may be possibilistic, maybe some hybrid. So the following are the basic. U and its arguments present some expert evaluation on the experiment or on the events or problems by some fuzzy compatibility levels in whole. Practically, this will be some matrix of decision making, as known in this multi-attribute decision making problems. K is an aggregation operators which are defined on the evaluations made decision making matrix, and these scalar values usually usually select the optimal decision from possible alternatives, or K may be rank these alternatives from the optimal to the least optimality, and so on. So practically, this system presents some temporal structure, but in this structure, this is the basic is inclusion relation. Inclusion relation defined on the bodies of evidence. So this relation, inclusion relation, practically creates the process of increasing of information for the decision precision. By the other words, in this case, we decrease some risks which may be happen for the decision process. So we have practically process of bodies of evidence. Okay. This inclusion is a knowledge precision relation of the bodies of evidence. It must allow reduction of an ignorance of uncertainty information presented by the basic probability assignment or focal probability M. Usually, this M is defined by the so-called knowledge ignorance measure. In our concrete models, the role of ignorance measure will use the non-specificity measure for the probabilistic body of evidence, may be used Shannon's entropy. In hybrid cases, may be used so-called Shapley entropy or other information entropy or measures. So on the basic concepts of our approach, which creates temporal environments for early decision-making methods based on the Defter-Schaeffer structure, okay? We call this process as a temporalization, or in other words, process of the increasing on information on the more precise decision generation. So this process is of knowledge increase or decrease of uncertainty as a risk minimization procedure. So it is necessary to explain in our problem the inclusion relation of one body to evidence into two other in terms of uncertainty of this environment, and also to define corresponding uncertainty measures and temporalization interrelations. So now formality presentation of our temporalization procedure. So in the role of contingents, which takes more precise information, in the role of these parameters may be used as a reduction of Shapley entropy, as an increasing of information on the precision of decision making, maybe use interval extension of informations of dissonance and confusion. initial ignorance measure as a hardly weighted linear entropy measure may be used as an initial ignorance measure. So, in other words, as a non-specificity measure, and if we are at the T step of our temporalization, we define conditional final ignorance measure from the T to the T plus 1 step by this formula, where this symbol indicates on the cardinality of sets. This is Cartesian product, and M is a composition of focal probabilities from T to T plus step. So we say that MT is given from the 0 initial steps. For the initial steps, we usually define this as a uniform distribution, and by the recursive procedure, we'll create some mathematical programming problem for the increasing process about the generation of more precise decisions. And this after solving a mathematical programming problem, we will receive focal probability on the following step. So this recursion may be repeated in whole, and we'll receive the enlarging process of bodies of evidence. So the basic equilibrium equation presented by this formula, which means the decrease of ignorance.
Excuse me, sorry, we stay now at the fourth slide. Maybe the problem is changing of slide.
No, here on display, the slides are going well.
Now slide number 4.
Okay.
You see slide number 4.
Equation number 4?
Yes.
Repeat, please.
Now we see slide number 4.
Slides.
No, not next.
You see it only slide number 4?
Yes.
Oh, this is, I think this is
the problem of changing of moving of slides.
Oh. It may be good situation if we run my video case, video presentation. We are on this slide.
We see slide number 4.
No, here on display, everything goes well.
It is maybe you need to start once more and maybe share your
okay, we will stop here now sharing and from the beginning. Yes.
I would suggest you, it's Irina speaking, I would suggest you just to move to another slide by clicking on the next step. This would be the simplest way. When you share a particular screen. They're asking you to share a particular screen. And after you just navigate and you share your full screen for this particular presentation. Yes, yes, correct. Yes, and after you can see that you can move to the slide number 5 by clicking on the slide now. Yes, correct. Yes. This is now what we can see. That's great. Now you can move very easier. Yes.
Is it correct now?
Yes, now it's correct, and we can go ahead. Beginning of the. Okay.
So let me continue my presentation from
Yes,
this
please.
slide 5. Yes.
Yes, yes. Thank you.
I return and come. So about some words about Debster-Schaeffer structure. The singletons information as elementary probabilities are the basic for the finite probability theories and statistics. But sometimes in the complex problems, maybe finite cases, the information as a mass of frequencies or probabilities, for example, in the some diagnosis environment, in medicine diagnosis problems and so on, we usually have no information about singletons. And this information is based on the some subsets of the universal or sets of possible elementary events. So this mass creates in the sum unity, and let's consider only such as events. Such as events are called focal elements, and their mass or frequencies or probabilities are called focal probabilities. So this pair with the strongly positive masses or focal probabilities and focal elements create so-called bodies of evidence or Debster-Schaeffer belief structure. This is some extension of two different qualitative theories of uncertainty and imprecision probability statistics on one side, and on the other side, so-called possibility theory by Zade and developed by Dubois and Prade. If we have only singletons as a focal element, we are in the probability environment. If focal elements create so-called nested sequence of events, we are in the possibility environment. But sometimes we are in the hybrid environment. So in general, we consider such a hybrid environment because we, for the starting, does not know where we are in probabilities or other environment. In this theory, the basic are informational theories: plausibility, quantitative measure, and beliefs. What is a belief? Believe information or believe or some of events which reflects some credible information on the, for example, the decision theories on the occurrence of some states of nature with respect to possible alternatives presents as a degree, as a total events of belief that the element belongs to the A. But plausibility presents more free information as a total evidence of plausibles that element belongs to the A. So in general, we consider some belief structure, and our extension of belief structure in the temporal environment as a process of belief structures look like by the following ways. So systemically, this structure may be presented by the following way. Let me give some sets of states of nature or acts or factors or attributes, or maybe symptoms, and let me give also some possible decisions, alternatives, maybe some symptoms and so on. T, some temporal structure. let A present some information about states as a Dempster's belief structure. The basic in our structure are U and K. U's components are some experts evaluations or fuzzy relations. In finite case, we are in the finite case as a fuzzy relations, as a matrix, decision matrix. And K are aggregation operators, which are defined on this matrix, or expert evaluations, which are and phases of this aggregation operators are scalar values. By K, we usually they are monotone aggregations usually, and K always select optimal from possible decisions, or K may rank all alternatives from the optimal to the less optimality direction. So practically, we'll construct inclusion process of Dempster-Shafer belief structures as a temporalization family, which guarantees increasing on information on the more precise decision making, and or by the other words, as a decreasing of some risks occurrence in the decision-making process. It is necessary to mention that our procedure may be constructed on the every decision-making method. So this decision-making method may be transformed as a temporal environment for the users of these methods, which may be used for the some temporal environments of decision-making procedure. How we can create this inclusion? By the so-called knowledge ignorance measure. In the role of measure, we use non-specificity measure, some entropy measures as a Shannon's, Shapley's, and others. So more quickly, dear colleagues, maybe it is necessary to mention that in the reduction of decreases or risks environment for the decision, we use Shapley entropy decreasing process or interval extension on informations, dissonance and consonance environment. Maybe use Hartley's weighted information or Shannonian information measure as a linear sum, as a weighted sum of focal probabilities. We have this symbol indicates of the cardinality of events. And in this case, the basic is how we can create transfer from the T step to the T plus step as a recursive procedure. This may be created by the conditional ignorance measure, where M is some composition of these two measures. So the basic equation, which guarantees decrease of ignorance or increase of knowledge, presented by these equations, by the concrete phases. And for the creation of this stability, it is necessary mention that what is the temporalization? If delta K is an increasing measure from the T to the T plus step is strongly greater, we say that information is preceded. In opposite case, we must search other means of decision making or demand a new expert knowledge. If we have information about singletons, on the singletons, all singletons, or states of nature, by this information, we create pair of expert evaluations on the focal elements as a pessimistic, optimistic ones, this pair. So instead of the U, we will consider pair as a pessimistic, optimistic one. So instead of the decision-making matrix presented by the experts in our some decision-making method, we will consider in future, such as made decision-making matrix, where instead of selectors as a states of nature, we will consider focal elements. So also case or criteria also will be dualized. Inclusion principle or criteria, it is necessary to include in our mathematical programming problem of the T-step of realization of our procedure. So the length of this interval must be tend to be 0, yes, for the precision of information. In the role of aggregation, in this aggregation, we use some non-additive aggregation integral operators, such as Shocket or Sugeno or other, or maybe additive aggregation tools as a Dempster's external expectations, and so on. It is clear that there exists some linear interdependence between focal probabilities from the T to the T plus 1 steps. We say that on the T steps, the focal probabilities are known, and we now construct a mathematical programming problem with the objective function as a entropy measures external principle, where constraints deals with the focal probabilities. 11 indicates on linear interdependence between these focal probabilities, and 12 independence on the probability theory for the finite case, okay? This is a criteria inclusion condition, which is included in the constraints of the mathematical programming problem. Now we consider maximization of non-specificity as a Hartley function maximal principle. Sometimes we use Shapley or Shannon's entropy in the role of object function. For example, we consider linear programming problem, which may be solved by well-known simplex method. So for the stopping criteria, we create the following measures. The S indicates as an average length of intervals from the first to the set for some S temporalization step. This equality is guaranteed by our steps of temporalization, and the percent indicator of the stopping may be used the following measure, where the EMF indicates on the such a step the latest experts evaluations were presented in our procedure. So this scheme indicates on our temporalization procedure. Let's now consider Debte-Schaeffer structure for the expertons theory. Let for every possible alternatives D, experts presented the evaluations by interval phases, where this is pessimistic and optimistic ones. So in this case, we create so-called lower and upper distribution, cumulative distributions for some alpha levels, and averaging values of these presents as an experton. Experton is a pair of these cumulative distributions. So after these, if we select some levels, for these levels, we create average value of midpoints of these intervals, and this value is called as a D's or alternative D's experton. Experton indicates on the on the level of occurrence or optimality of some possible alternative. More concretely, let these some set of possible alternatives some group of experts which make evaluations by the interval forms as in the table 1. After this, we select some A as focal elements, and at the E step, we create the environment for the evaluation of Debster-Schaeffer belief structure. Now on the steps of our temporalization, it may be for the initial case, we take in the role of focal elements singletons, and uniform distribution is selected as a focal probability. Let me give some expert evaluations in the TIF steps. We have some linear connections by this probability, focal probability. This is inclusion principle of the intervals evaluations. So if we roll over objective function is taken Hartley measure, the following maximization principle is taken. This is linear equation systems as a constraint for this optimization problem. In some cases, may be taken in the role of objective functions other information measures. Sometimes when we have not one but several objective functions by non-linear constraints, we usually use some programming applications for example, by IBM C complex optimization studio and others. So shortly on the application of this temporalization structure in the information security risk assessments. The main process of an information security management systems implementation usually is information security risk assessment. So this application recommends a qualitative methods based on experts' opinion and fuzzy technology for the security risk assessments. For the primitivity, let's consider some process in the ACMS or management systems and experts which reflect their knowledge on this process, and they make some evaluations with respect to possible such as types risks parallelly, and they create their expert knowledge streams with respect to following attributes. These attributes are taken by the experts. So practically, from our previous slides, we have some knowledge reflection stream of experts, and if we use our procedure of temporalization for this case, and let experts, we have 4 experts, let experts presented for the starting by following information, interval evaluation of the reflections on the possible decisions with respect to alternatives. After accumulation of these decision-making metrics into the one decision-making metrics, and starting our procedure of temporalization, for the first steps, we create following information, where these numbers indicate on the possible occurrence of risks. And you see there, in our case, it's the first step, the high risk is more optimal because this risk has more high level, okay? But if we continue using expert knowledge streams in our procedure and take into account these mathematical programming solutions, we continue this procedure, and when experts finish their their presentation, in this case, we usually finish our temporalization structure and some more precise decision will be generated. For our case, for this exam, on the table 16, this information on the precision decision is presented. So after the second step, you'll see the second alternative as low. It is not seen. Yes, the more precise and more optimal decision will be second or low risks. So our decision as a precision decision will be low risk instead of high risk. Okay. So in many authors' publications, the multi-attribute decision-making methods are used in the military problems, which are listed in these slides. So after temporalization of these methodologies, we'll have the opportunity for the creation or generation more precise decisions. So by this sentence, I'll finish my presentation, and thank you very much for your attention.
Thank you very much, Professor Sirbiladze, for your presentation. And now we have short time for question and discussion. Welcome. Any questions, please?
Stop sharing.
Yes.
Okay.
Stop sharing.
Okay, I have short questions, if it's possible, concerning expert-based assessment in area safety and security issue. From one side, we need to use expert experience. Yes. On the other side, there is a problem of dependency of accuracy and trustworthiness of assessment on expert knowledge. And how we can join these two tendencies? I mean to provide trustworthiness of final assessment in safety and security.
Yes, thank you. If we create our applications on the management of information security problems in the temporalization environment, we create such an environment where we have opportunity to decrease possible risks with the selection of optimal decision. So practically, we create a dependent environment of the system.
Mm-hmm.
Dependency is the basic in our goal problem, because this procedure is guarantee for the creation dependence environment for the application of such as systems based on this methodology.
I see. Thank you. And very shortly, what about ChatGPT as expert? Is it possible now? What is your opinion? ChatGPT, popular.
Of course, it is going.
Application.
It's useful tool, of course. Yes, we agree. And very interesting. ChatGPT.
Yes. No, this system is more applicable today in the world. Maybe some connections, our methodology and this applicability of such a systems may be developed in future.
Okay, hence we can consider ChatGPT as one of the experts, or not? Okay, it's a rhetorical question. Okay, I see one more question very shortly, please. Professor Shmilova.
Good afternoon. I have questions. No, I think in GPT we all as experts, but in your research, who were experts? They have qualification, experience in job. Who our expert in fuzzy logic or estimate?
We believe that experts which may be included in our temporalization structure must be by high-level experts. So the problem of selection of high-level experts is another field of investigation. Okay. This is very important and important problem, but from another field of investigation.
Thank you. Very interesting. How many experts were? How many?
Statistically, it may be about 10 experts because expert evaluations as a source of quantitative information is different from the statistical. Because in the statistics work some limited theory, yes, for the creation of credible approximations. But in expert knowledge streams evaluation theory, such as fundamental theories does not work. We have only one possibility. This environment of work, such as debate system based on the such as temporalization methodologies, work or does not work.
Thank you. I understood.
Okay. Sorry, but time is over for this session. Okay, Professor Zaslavsky, very short question. This is the last one.
I would like to ask you, and you consider different weight for criteria with process decision making and modeling, because it's important.
Yes.
Also. Yes. And
yes, we have some freedom in this choice of criteria or objective functions because this selection depends on the preferences of future users of such a systems and in their knowledge on the knowledge on the information, general modern information theory.
Okay.
Okay. Thank you very much, Professor Gia Sirbiladze, for your presentation. Thank you for your cooperation and hope for our next meeting on the DESSERT and other conferences.
I think all will be right for us and at first for you, for everyone. Thank you very much for your attention. Thank you.
Thank you. Thank you. Okay, dear colleagues, let's go ahead. Now we will continue our conference on the session modes. We have now time for workshops, 3 workshops. First one is modeling. Professor Semenov, Professor Kuchuk. Second one on intelligent cyber-physical systems. Professor Lysenko, Professor Sachenko, Professor Markovsky. And third one, we will start next workshop related to topic of digital infrastructure for small modular reactors, for energy system, and so on, safety and security. And Professor Brezhnev, Professor correspondent member of National Academy of Science of Ukraine, Sergei Sauch, will moderator of this workshop. Please, a few minutes interruption, and after that we will continue.
No break.
Okay.
It's already running, so you can attend the section.
Yes. Please start our work in session. session. Next, our plenary session will be tomorrow, according with our program, at 9 a.m. of Athens time. Thank you.